Greetings, chemist students. This is Mr. Braun, and today we're going to talk about the pre-lab for Hess's Law, which is computer lab number 18. The opening paragraph here states that you're going to use a calorimeter to measure the heat released by three different reactions. Okay? According to Hess's Law, the heat of reactions of one reaction should be equal to the sum of the heat of the reactions of the other two. This concept is sometimes referred to as the additivity of heats of reaction. So, the objective of this experiment is to confirm that law. If you look, here is the very first reaction that you're going to see. Solid sodium hydroxide dissolved in water to form aqueous solutions of sodium ions. The second reaction that you're going to see is that there's going to be solid sodium hydroxide reacting with an aqueous solution of hydrochloric acid. So that's hydrochloric acid that is dissolved in water. Okay, so you're going to form water and an aqueous solution of sodium chloride ions. And finally, the third reaction that you're going to see is you're going to take a solution of aqueous sodium hydroxide and a solution of aqueous hydrochloric acid, and you're going to react those two solutions together to form salt, which is aqueous sodium chloride, and water. So those are your three different equations right there in the introduction. The objectives of this experiment will be to combine equations for two reactions to obtain an equation for a third reaction. Use a calorimeter to measure the temperature change of the three reactions. Calculate the heat of the reaction, delta H, for the three reactions, and use the results to confirm Hess's law. Right here is the setup that we will be using for the calorimeter. We've used this before, so that's nothing new. The big thing to remember is make sure that your utility clamp is not so tight that you break the temperature probe. Okay. Now, a pre-lab exercise that you need to do, it says in the space below, combine two of the above equations algebraically to obtain the third equation. So you have to look at those the three equations that we just talked about and see which two add up to equal the third one. All right? Now, when we do the procedures, obviously we're dealing with acids and bases here, sodium hydroxide and hydrochloric acid, so we need to wear our goggles at each time. We're going to open computer lab number 8 of the chemistry with Vernier. You're going to have your styrofoam cup in a 250 milliliter beaker, and then you're going to add different things to the beaker. Okay, so that will be the big change. So if you look, here's reaction 1. When you get down to reaction 2, we are repeating the steps, but we are adding 100 milliliters of a 0.50 molar hydrochloric acid instead of water. And then on the third reaction, we are following the same steps 3 through 8, and we are just adding different substances, because remember that both of the reactants are going to be aqueous solutions in reaction number 3. Now, when we are processing the data, we have a data table that's going to be the big thing. I'm going to go through and check all your calculations when you turn these in. But the big thing is going to be following the directions for the processing the data. Here it says determine the mass of 100 milliliters of solution for each reaction. Now, it is assuming that the density of each solution is 1.00 grams per milliliter. If that is the case, if the density is 1.00 and I have 100 milliliters of the solution, I'm also going to have 100 grams, because 100 grams divided by 100 milliliters will give me 1 gram per milliliter. So when we have a density being 1.00 grams per milliliter and we have the amount of milliliters, that is the same amount that the mass in grams will be. Now let's talk a little bit about the assumptions that we are making with this lab, okay? The very first assumption is that the specific heat capacity, the C sub P, for the various aqueous solutions is assumed to be the same as water. So we're taking the C sub P for these solutions to be that of water, which is 4.18 joules per gram degrees Celsius. In fact, they're very near the same. So that's right here, the CP, we are assuming that it is that value for water. The second assumption is what we just discussed here. We're assuming that the density of each of the solutions is 1 gram per milliliter. Okay? Since this is very nearly the case, we know that 100 grams will be 100 milliliters. The final assumption is that the procedure for reaction 3 uses the assumption that initial hydrochloric acid solutions and sodium hydroxide solutions are of the same temperature. Now, I've mixed these chemicals up beforehand, so they should be at the same temperature. So we are assuming they're at the same temperature. Now, once you're done with the lab, you need to make sure that you have your data for the lab. So this part right here should be filled out, the change in temperature. The initial temperature minus the final temperature is the change in temperature. Actually, check. The final temperature minus the initial. So T2 minus T1 is the change in temperature. And you should be able to determine that right here, the change of temperature. Okay, you need to have the mass of the sodium hydroxide for 1 and 2. Now, you won't have a mass for number 3 reaction because we do not have a solid. Remember, that is an aqueous solution. Okay, the total mass of solutions, once again, we determined with the density. We can determine the mass if we have the density of the solutions. Okay? Make sure when you're doing your calculations, you read through all of these 1 through 7 because it will help you to determine what you're doing with the lab. Okay? This is Mr. Braun. We have been discussing the pre-lab for computer lab number 18, Hess's Law. Chem 1 students, let's investigate.